yeah, in this video we've got ourselves one heck of a word problem, and it has everything to do with the graph, or a piece of a graph of a parabola. Let's check it out. It says your friend accidentally drops her cell phone off the top of a building from a height of 45 feet off the ground. The function h of t equals negative 16t squared plus 45 represents the height of the phone h of t seconds after your friend dropped her phone. Okay, so all of that basically says, well, let's read the last part. The graph of this function is shown to the left. Basically, we've got that this x-axis is t, the time in seconds, and the y-axis is h of t. So I'll put h of t, that's the height of the cell phone, t seconds after the cell phone's been dropped. So it gets dropped and it goes down, and now we're going to interpret the graph. So this is all about interpreting the graph. After approximately how many seconds will the cell phone hit the ground? Well, if this axis represents the height in feet and this represents the time in seconds, we just need to trace the graph and see when is the height 0, right? Because this would be when h of t, or the height of the cell phone, is 0. That's when you hit the ground, right? Assuming ground is 0 feet. So where does that happen? Well, 0 feet is right here. So we are going to go to the 0 foot mark and just kind of trace it along with our eyes and trace. Here we go, right there. So that's approximately, let's see, this is broken into 1, 2, 3, 4, 5 pieces. So 1.2, 1.4, 1.6, about 1.7 roughly. So t is about 1.7 seconds. That could be 1.75 seconds. All right, so that's the approximation. It's where the graph crosses the x-axis, because that's where the height is 0. That's a huge idea, peeps. Huge, but simple. What is the significance of the y-intercept of the graph? Well, let's look at the y-intercept. Here we have the y-intercept, and it's approximately, well, that's at 45. Well, that's at time 0, right? That's the point 0, 45. Well, that is the height of the cell phone at time 0, which we're told right here. The height of the cell phone is 45 feet when it's dropped. That's when the timing starts. So the significance is that's the initial height of the cell phone. Approximately how high off the ground will the cell phone be after 1 second? So now we're being told that t equals 1. Well, there's two ways we could do this. We could use the graph. We could look at 1 and go up and see, oh, that's right about here. So that's approximately what? This goes up by, I think, 2s, so 22, 24, 26, 28, about 29 feet. So that's how we use the graph to do it, or we have the function. You could do h of 1. Plug in 1 to find out what the height is. So h of 1 is negative 16 times 1 squared plus 45. 1 squared is 1 times negative 16 is negative 16 plus 45. Is equal to 29. So we actually hit the nail right on the head. The function gives us the exact height. The graph gives us a nice approximation. So the height of the phone is 29 feet after 1 second. So this word problem really just saying, yeah, plug in 1, or look at the graph at 1 and trace it up with your eyeballs to see what the height is. Number 4, is the portion of the graph below the x-axis relevant to the problem? So we're talking about this part right here. And the answer is no. We don't have negative height. The phone didn't bury into the ground, right? We didn't have like the top of the building, and here's the ground, and the phone just went whoosh, right through the ground. So no, it's not relevant to it. And I just wanted to ask you that part of it. Kind of interesting. So the whole purpose of this video, folks, is to see how we can get information from a graph very quickly. Like I might not have given you that function and said, what was the initial height of the phone? And you would have said, oh, it's about 45. It's the y-intercept. We know we hit the ground when we cross the x-axis because that's where the height is 0. And we can approximate heights of the phone anywhere from 0 to where it hits the ground just by looking at an x value and tracing the x value up to the corresponding y value. There is a ton of information from graphs, and graphs helps you to approximate values. But as we see, functions give you the exact value each time. Very awesome stuff. Love this word problem. See you next time.